So in this tutorial, we're going to look at section 3.2, which talks about how to prove lines are parallel. Don't worry about proofs. We're not going to do them yet in full. You might see bits and pieces. But in this particular tutorial, the difference between this section and the previous one is that in the previous one, we already knew our lines were parallel. In this one, we don't. What we do know, though, are a pair of angles that have properties that parallel lines follow. So when I look at this picture, I have these two angles in red, which I know to be corresponding angles. And if I know that I have corresponding angles and they are congruent, so I have to check that they're congruent as well, then I can tell you that lines L and M are parallel. So L is parallel to M. So this tells me that I can make a conclusion about these lines and that they are parallel because I have congruent corresponding angles. And this has a special kind of name, and it's basically the converse of the corresponding angles postulate. So we say that this is the converse of the corresponding angles postulate. So this is another reason. So if you start with a couple angles, you know something about them, you can conclude something about the two lines, and hopefully you will know that they are parallel. So we have these converses for all 5 kinds of angles. We have the converse of alternate interior angles, we have the converse of alternate exterior angles, and so on and so forth. So let's take a look at a specific problem that's in your book and see how we can use this. Okay, so let's take this example. We have 2 angles that we should know something about, and the goal here is to determine what must x be in order for L and M to be parallel. So first of all, just by looking at this picture, I can tell that these 2 angles are on the same side of the transversal, so same side, and they are on the interior of lines L and M. So those would have to be same side interior angles. And what I know about same side interior angles from my knowledge already, as long as lines L and M are parallel, then these would have to be supplementary. In other words, they have to add up to 180 degrees. If I can prove this to be true, then my lines L and M are automatically parallel. So how do I set up an equation to solve for x? Well, I'm going to do 7x minus 8, and I'm going to add that to 62 degrees, and that should give me 180 degrees. So the way that this converse comes into play is that I know that I start off with a pair of angles, and as long as they are supplementary, this is where the converse part comes in, then I have parallel lines. So all of this is all from the converse of same side interior angles. Okay, so let's do this. So 7x plus 54, that's negative 8 and 62 together, equals 180. Okay, I then subtract 54 from both sides, which is 126, and then I divide both sides by 7. These 7's cancel, and x is equal to 18. So the only reason I know that this is true, or the only way that I know that these 2 lines, L and M, are parallel, is if x equals 18, and that's the only instance where L will be parallel to M. And that concludes this tutorial.